Hi, hello everybody. So this is the video where I'm going to show you how to simplify rational expressions. And because this is in the same topic number on our workbook, I'm going to cover these three topics, which are simplification, multiplication, and division. They're very, very similar. And we put them all together here for you to make it easy to watch the video. Now, the technique for simplification, multiplication, and division is the same. So for all of these three topics, the technique is we have to factor the numerator and denominator completely before either simplifying, multiplying, or dividing. So we kind of have to remember all of the different techniques dealing with, factoring that we cover in the previous section. So here they are, greatest common factor. So remember, this has to be done first. Grouping, this occurs in groups of 4. And then we have the two trinomials. These are the most frequent. When we have trinomials where the leading coefficient is 1, a is equal to 1, or when a is greater than 1. So this is the AC method. Have difference of squares. So these are two terms with a minus sign in the middle. And then we have the sum of cubes and difference of cubes, which very likely for these problems won't really show up very often. Okay, so we'll take a look at the simplification example. And I already wrote them here to make the video go a little bit faster. And I am going to simplify. We'll start with 13.10 first. So these examples are in the workbook, but I'm going to do them here so that way you have for your notes. So the technique is, as I said before, you will simplify the numerator and the denominator completely before simplifying anything or multiplying or dividing. In this case, it's just to simplify. So we take a look at the numerator and we see what we can simplify in the numerator. So we see that the two terms have a 5 in common. That's my GCF. I will pull out the 5 and then we'll divide 20 by 5 and minus 5y divided by 5. Okay. And we factor the denominator. So we have to remember what kind of factoring technique this is. This looks like difference of squares, right? Two terms and a minus in the middle. So the technique says, right, split the variable. One is plus, the other is minus, and square root of this number. Okay, the numerator is completely factored. The denominator is completely factored. And then we have to see if we can simplify identical factors on opposite sides of the fraction. Now, be very careful. 4 minus y kind of looks like y minus 4, but it's not the same. They're off by a minus. So the way to handle this is I'm going to do it in 2 steps. I'm going to rewrite the 4 minus y in a different order because I want you to see how similar they are, but not quite. So minus y plus 4, y minus 4. So it's like they're off by a minus. So I am going to factor the minus out of the numerator. I'm going to factor a minus 1 times the 5. And now this becomes y, and the positive 4 becomes minus 4. Denominator stays the same. And to make sure that you got this right, you can multiply it back. Minus 1 times y, minus y, minus 1 times minus 4, positive 4. And now these match. Y minus 4 and this y minus 4 cancel. And I am left with minus 5 in the numerator. Y plus 4 in the denominator. And that's my final. Okay. So technique, factor numerator completely, factor denominator completely. And once the factors are identical on opposite sides of the fraction, you can simplify them. All right, how about the second one? So we take a look at the second example, 13.9, and we take a look at the numerator. There's nothing I can really factor in the numerator. So the numerator stays the same. It's less work for us. The denominator, I see something like this, and we have to remember what kind of factoring technique this is. Really, we can't do GCF. They don't have any terms in common. It's not grouping because it's only 3. It looks like a trinomial, and this is my A, and A is greater than 1. So the technique is the AC method, which means I have to find two numbers whose product is 2 times the -1. So my product has to be, and I'm going to write 2 here, even though I know it's -2. My product has to be 2, and my sum has to be the middle term, -1. Okay, so this is, like I said before, you have to remember the different techniques of factoring. So the product has to be 2, the sum has to be -1. Well, the only two numbers that can give me a product of 2 is 1 and 2. And now I have to adjust them, their signs, so that the sum is -1. So how can I get a sum of -1 with 1 and 2? And so one of the two has to be negative, and obviously is the 2. So 1 plus -2 is -1. That works. And 1 times -2 is -2. Yes, so this is exactly it. So the technique says, once I find these two numbers, I am going to rewrite the middle number using these two values. So 2x squared plus 1x minus 2x. So these are the two numbers right here that came from here. -1. At this point, what do we do? Well, we have 4 terms. We're going to factor by group. So we will look at the first 2, and then we'll look at the last 2. Out of the first pair, what can I factor? I can only factor an x. And I will get 2x plus 1 in here, right? 2x squared divided by x, 1x divided by x. Out of the second term, remember what I said before, whatever the sign is, you have to factor. They also don't have anything in common other than a 1. So I have to write that 1 here. And -2x divided by -1, -1 divided by negative. I can see that 2x plus 1 is a common factor, so I will factor that again. And in the second parentheses, I will write x minus 1. So this now goes right here, because the 2x plus 1, x minus 1, is the factoring of 2x squared minus x minus 1. And now look how easy it becomes. I have 2x plus 1 in the numerator, 2x plus 1 in the denominator. They both cancel. And what is my final answer? Be very careful. The answer is not x minus 1. In the numerator, I don't have anything other than an invisible 1. And in the denominator, I just have x minus 1. Okay? So again, to simplify, factor completely the numerator and denominator. Once they match on opposite sides of the fraction, they can be simplified. And that's all we have to do for simplification, right? It's very straightforward, provided that we remember, as I have here, the different techniques of factoring. Now, for multiplication, we'll do this example. Same thing. We'll have possibly 4 terms to simplify, as you can see here. And we have to simplify in terms of factoring completely. And we cannot multiply as we would normally multiply two polynomials. We have to fully factor them first. So actually, there's not going to be any multiplication. It's just factoring and simplification. All right, so let's take a look at the example I have here. So I have this example, and we have to take a look at what can be factored. So it looks like this is a trinomial. This is difference of squares. This is regular GCF, and it looks like can't simplify or I can't do anything with this, but you will see I will be able to factor a -1 out of this thing. So we'll see. It doesn't really matter how you begin. So I'm going to write the two fractions here, and I think I'm going to do the 4x minus 8 first because I think it's the easiest one. So this is GCF. So what do these two terms have in common? Yes, they have a 4 in common. So you pull out the 4. And then inside the parentheses, I get x minus 2, right? So 4x minus 8, this is correct. And then I think I will do the x squared minus 1 because I recognize this as difference of squares. Again, that is very easy. Difference of squares is pretty fast. So we'll split the variable. 1x goes here, 1x goes there, plus, minus, square root of 1 is just 1. Okay, so that's that. The x squared minus 5x plus 6 looks like a trinomial with a1. So aside here, I am going to factor the x squared minus 5x plus 6. So again, for the trinomial, I need two numbers. The product of the two numbers has to be equal to c, which is 6. So I can either have 1, 6, or 2 and 3. Those are my two possibilities, and I don't have anything else. Now, out of these two pairs, I need one of the pairs whose sum is the -5. Well, it looks like maybe I can get a -5 with 1, 6, and maybe I can get a -5 with 2, 3. So I'm not quite sure which one. So you may have to try them both. So if I say 2, 3, in order to get a -5, both would have to be minus. Yes, that's correct. And then I gotta check to see if I multiply these two, I get back a +6. Yeah, I do. So this seems to be it. But you might think, well, you know, Professor, so, but how come I cannot get, for example, 1 and -6? 1 plus -6 is my -5. Yes, that's correct. But what happens when you multiply these two now? When you multiply these two, you get -6, which is not what you need. You need a +6. So this one is out. My answer is -2, negative. So this is only going to work for one of the pairs, always. You can always check. Okay, in this case, it turns out that the answer or the pair that we're looking for is -2, -3. Once you find the pair, all you have to do is write the polynomial in this form, or write the trinomial in this form, and you were done. So the x squared minus 5x plus 6 is x minus 2, x minus 3. And you can check if you want it by foiling. Okay, we're not going to do it here, but you can see x squared and x times -3 minus 3x minus 2 times x minus 2x combined gives you a -5, and -2 times -3 is +6. So that checks. And in here, I have a feeling that I will have to factor this somehow, and I'm going to write the 1 minus x as -x plus 1. So I'm just flipping the order, and now I'm going to factor a minus 1. Okay, and you see why. Once I factor a minus 1, inside of the parentheses, I will get minus x divided by minus 1, x. 1 divided by minus 1, minus 1. And I have a feeling that I'm going to need this, so I'm going to leave it in this format. So normally this is what happens. Now, everything is completely factored. This numerator is factored, this numerator is factored, this denominator is factored, and this denominator is factored. So now, and notice, I am not multiplying anything. I leave it in multiplication form because now this x minus 1 cancels with this x minus 1 on opposite sides of the fraction. This x minus 2 cancels with this x minus 2. I can't cancel the x minus 3 with anything or x plus 1, but I will leave them in product form, x minus 3, x plus 1, and there's a minus 1 times 4 here. Now I can't leave a minus in the denominator, so I'll leave the 4, and I'll write the minus in the numerator. So this is my final answer for that problem. Okay, so notice, even though this is a multiplication problem, we factor every term and we leave it in multiplication form. My final answer is the simplified expression as you see here in multiplication form. Okay, now in the case of division, if you remember division of fractions, this is identically the same. Before you proceed with the operation, you are going to turn the problem into multiplication. And how do we do that? Well, I am going to show you how to do that in case you forgot how to divide fractions. But after we turn the problem into multiplication, everything becomes identically the same as before. Okay, so here is the problem. And I'm going to erase this part right here before we proceed. So recall that if we have something like this, 3/4 divided by 1/2, the way to do this problem is we're going to keep the first fraction the same. We're going to change this to multiplication, and we're going to flip the second fraction. So 1/2 becomes 2/1. And then you can multiply. 3 times 2, 6, 4 times 1, 4, and then simplify the final fraction by 2 to get 3/2. We're going to do the exact same thing here. So this problem, before you do anything, you're going to rewrite it as, this is my first fraction, stays the same. The division turns into multiplication. This goes to the numerator. This goes to the denominator. So this is before you do anything. Okay, this is absolutely safest this way. And now you have a multiplication problem just like the problem before. And it's very easy to do. So we'll do it again. At this stage, all we do is factor every term. So we'll do this again. I'm going to begin with this because there's nothing to factor, so I'm just rewriting it here. This expression is simple too. It's a simple GCF. They have an x in common, so I'm going to factor an x, and I'll get x minus 3 here. These two now are trinomials with leading coefficient 1. So I'm going to do them on the side right here. And again, like I said, you will have to remember how to factor these things. So for the x squared plus 5x plus 4, I will need a product that's equal to 4. So either 1 and 4 or 2 and 2, one of the two. And out of these two pairs, I need a number whose sum is 5. So obviously you can see it's 1 and 4. Okay, this guy is out. So once I find the numbers, all I have to do is write them out as x plus 1 and x plus 4. So that is completely factored. And I'm going to do the same thing for x squared plus x minus 12. So I need two numbers whose product is negative 12, but I'm going to write as 12. Ignore the sign. So I can have maybe 1 and 12, 2 and 6, or 3 and 4. These are the three possibilities. There's nothing else in terms of whole number. Out of these three possibilities, I need one whose sum is 1, right? There's an invisible 1x right there. This is too far apart. This is too far apart. So the only possibility is 3 and 4. Obviously, if I add 3 and 4, I get 7. I don't get positive 1. So I need to tweak their signs so that combining 3 and 4, I get a positive 1. Well, the only way to do that is if 3 is negative. So now I have 4, or negative 3 plus 4 is positive 1. And once I multiply them back, I get negative 12. So this is it. This is my number. And I'm going to write it just like I wrote the other trinomial as x minus 3 using the minus 3 and x plus 4 using the 4. Now notice I am not multiplying anything. I'm leaving in multiplication form. And at this point, I am going to simplify common factors on opposite sides of the fraction. So take a look at the x plus 4, x plus 4, x minus 3, x minus 3. And notice there's an x here and there's an x there. So these two x's go. At this point, there's nothing more to simplify, and the numerator has x plus 1, and the denominator just has a number, which is my final answer for this problem. Okay, so this is how you do division. So the very first thing you do is invert or change the division into multiplication, and then proceed as before, factoring everything. All right, so this is the section topic 6.1, simplifying, multiplying, and dividing rational expressions. All that you have to remember are these techniques and applying them correctly to finish the process. Okay.